So this is our upper half of the ellipse. We're going to, hopefully in a different color, oh good, in a different color here, we're going to sketch a rectangle inscribed in there. And this length here ought to be x, which makes this 2x. This length here ought to be y. So the area of this thing ought to be 2xy. And so then we'll go over here and we will figure out what y is in terms of x. So we've got x squared, or we could figure out what x is in terms of y. It doesn't really matter. We're going to have 1 minus x squared over 4 equals y squared over 9 if we subtract the x squared over 4. We can multiply by 9, so we'll have 9 minus 9x squared over 4. And then we're going to square root. So we end up with y equals 9, the square root of 9 minus 9x squared over 4. Good with that? People in the Zoom, are you good with that? Cool. And then what I'm going to do is I'm actually going to turn this, I'm going to give this a 4 here and a 4 here. Because if I do that, I'm going to get 36 minus 9x squared in there. And then it's over the square root of 4, so just over 2. So the area is x root 36 minus 9x squared. Does that make sense to everyone? Emily? Yeah? Everybody in the Zoom, good with that? Yeah? So we want a prime. A is x root, what is it, 36 minus 9x squared. A prime ought to be done using the product rule. So x times the derivative of root 36 minus 9x squared, which would be 1 over 2 root 36 minus 9x squared times the derivative of 36 minus 9x squared, which is negative 18x. And then plus the derivative of x times the square root of 36 minus 9x squared. And then we're going to want to simplify this to make this a negative 9x squared up here. And then I'm going to put plus 36 minus 9x squared. I'm going to multiply both the top and the bottom of this by root 36 minus 9x squared to get a common denominator. And then I'll have negative 18x squared plus 36 over root 36 minus 9x squared. And if we're going to look for when that's equal to 0 and when it's undefined, anything that makes the denominator of this thing equal to 0 makes it undefined. But those values are just going to be, I mean, you can see that that'd be when x is 2 or when x is negative 2. And when x is 2 and when x is negative 2, well, there's no rectangle to even draw, right? Because if x is 2 and x is negative 2, it's just a straight line. So those are where your minimums would occur. So really, we're just concerned about when the numerator of this, 36 minus 18x squared, is equal to 0. And so we add that 18 over, we divide by the 18, we get x squared equals 2, or x equals root 2. And we'll put that on the sign chart, 0, root 2, and 2 would be the endpoint, because that's as far over as we can go for our x values. Plug in 1, let's say, because that's between 0 and root 2, and you end up with a negative over, a positive over a positive, so you get a positive, and it's increasing. Plug in something like 1.9, and you end up with a negative over a positive, and it's decreasing. So your max area occurs at x equals root 2. And if you want to figure out what that max area is, that would be root 2 times the square root of 36 minus 18, which ought to be 18. Square root of 18 times the square root of 2 is the square root of 36, which is 6. Good? That help? Yeah? Does that make sense to everybody at home?
Yes, sure.
Oh, wonderful. Great. Thanks for answering, Sid. That was Sid, right? Sounds like Sid. Yeah. Thanks for answering. All right, what do we think? We want to do another, you want to do another graph one, Emily? You want to do something different? All right, another graph one it is. I'll give you guys 15 minutes to work. Ready? You guys ready over there? Yeah? Yeah? Emily, you good? Yeah. Wow. Looks like you've written a lot down on it. That's great. All right, we're going to integrate from negative 2 pi to 4 pi. For f of x. And so f of x is g of x minus cosine of x over 2. So to integrate from negative 2 pi to 4 pi of g of x dx minus, let's separate this into two different integrals, the cosine of x over 2. So for g of x, we'll just integrate this. This is a triangle with a base of 6 pi and a height of 2 pi. So that'll be 1/2 of 6 pi times 2 pi. And then minus. And then this one we'll need to do a u substitution on. Hopefully you can do that in your head, but if not, you can write it out. And you put your 1/2 in, you put a 2 on the outside. So we end up with minus 2, and then this becomes an integral of just cosine u du. And so that'll just be the integral of cosine, which is sine. So this is minus 2 sine of u. And we got to evaluate that from negative 2 pi to 4 pi. So what do we get? We get 6 pi squared minus 2 times the sine of 2 pi. What's the sine of 2 pi? 0 minus the sine of negative pi, which is 0. So 6 pi squared. Everybody good with A? Great. All right. Part B. Find all x values where f has a critical point. Well, that means f prime needs to equal 0. Well, what's f prime? F prime is g prime plus 1/2 the sine of x over 2. If you take the derivative of negative cosine x over 2. So plus 1/2 sine of x over 2. And we want to know when does that equal 0. So how are we going to figure out when that equals 0? So there's only two different values for g prime, right? If we look over here, g prime is equal to what here? From negative 2 pi to 0, what is g prime equal? 1. And from 0 to 4 pi, what is g prime equal? Negative 1/2. So we're going to then plug each of those in and see if we get any values on those intervals. So we're going to say g prime is 1. So 1 plus 1/2 sine x over 2 equals 0. And that's only for negative 2 pi to 0. And then the other one, what did we say was negative 1/2 plus 1/2 sine x over 2 needs to equal 0 for 0 to 4 pi. And so now we'll just solve those. So the first one gives us, if we subtract the 1 over and then multiply by 2, that's going to give us the sine of x over 2 equals negative 2. When does that happen? When you take the sine of something and get negative 2. Never, because sine is only between 0 and negative, or negative 1 and 1. And then for this one, we'll end up with, we'll add that over and multiply by 2. We'll get sine of x over 2 is equal to 1. Okay. And that definitely happens when is sine equal to 1. When the angle is not 3 pi over 2. That's negative. But 5 pi over 2. Next one would be 9 pi over 2, and so on. So if we multiply those by 2, we get x equals pi, 5 pi, 9 pi. So the only one that makes sense then is x equals pi. And then we also need to figure out when the derivative might be undefined. And so at 0, what is the slope coming from the left? It's 1. And the slope coming from the right is negative 1/2 here for the g part of it. G prime itself is undefined at 0. Therefore, f prime must be undefined at 0 because I have undefined minus some number. And so that's also undefined. So we'll say also at x equals 0 because g prime is undefined at x equals 0. So 2 critical values. Good or no? At home, are you all good with that? Great.
Sure.
Oh, good. Okay. And part C, h of x is the integral from 0 to 3x of g of t dt. We want to find h prime of, what was it, negative pi over 3. So we're looking for the derivative of h. Derivative of h should be g of 3x times the derivative of 3x, so 3g of 3x. And if we want to find h prime of negative pi over 3, that ought to be 3 times g of 3 times negative pi over 3, which is negative pi. And so then we'll just have to figure out what g of negative pi is. Negative pi is right here. So if we've gone over pi, we must have gone up pi. So that ought to be 3 times pi. Good or no? Tori, you got that? Melanie, you're good? Okay. Emily, you're good? Oh, okay. Good. Everybody in the Zoom, you're good there?